This lesson will be about graphs of rational functions. So before we actually start doing any graphs, I'm going to do a little bit of review. And the first thing I want to mention is the domain. Now, if you remember, the domain is all possible x values. For example, if I ask you to find the domain, we have a few things that we have to look at. We always want to look at square roots, and we want to look at denominators. So square roots, you can't have negative values for x, and denominators, you can't have zero values for x. So actually, the ones that we're going to be looking only at for this section are the ones with denominators, because we're working with rational functions, which are functions that are a fraction. So here's my first example. F of x equals 3x minus 4 over 5x plus 10. So when we look at the domain here, we are going to be setting the denominator equal to 0, 5x plus 10. We don't actually really care about the numerator here. The numerator can be 0, that's fine. We want that to be not equal to 0. So then to solve that out, you just solve this equation, and you end up getting that x is not equal to negative 2. So that was how we found the domain. You probably remember this from past classes. Occasionally you will have a more complicated denominator, which is fine. So let's say I have like x minus 4 over x squared minus 2x minus 24. So I am going to do the same thing. I'm going to set that denominator equal to 0. And actually find out where it's not equal to 0. That's what I want. In order to solve this out, I do have to factor. Remember, we're looking for things that multiply to negative 24 and add to negative 2, which is going to be negative 4 or negative 6 and positive 4. So my two answers for my domain here are going to be that x is not equal to negative 6 and x is not equal to 4. So that's my domain. That's actually going to transition us into an important idea that's called asymptotes. You may have heard this before, and we'll talk about that in just a sec. It's going to happen. So our biggest rule of thumb is when we're graphing rational functions, we need to find our intercepts and asymptotes. And just to kind of clarify, I didn't write a full definition of this, but a rational function is basically a function that has a fraction, and it's always going to be where you have a variable in the denominator. So the fancy definition is that it's a quotient of polynomial functions, but the basic idea is that it's a fraction with a variable in the denominator. Okay, so let's talk about intercepts first. So if you recall, you find the y-intercept by setting your x values equal to 0. To find the x-intercepts, and with functions, you are not going to have more than one y-intercept, but with you are sometimes going to have more than one x-intercept. You'll notice I made it plural. Generally, we say that these are the x values when y equals 0. So if you're looking at things at one of these functions, when you set y equal to 0, it's not as straightforward as you think it might be. Actually, what we're going to do is we are just going to only look at the numerator. And I'll show you what I mean in just a sec. The next two things that we need are our asymptotes. So an asymptote, just a little definition here. You might remember this. It's an invisible line that the graph gets closer and closer to but never touches. So we have two types of asymptotes. We have our vertical asymptotes and our horizontal asymptotes. So the vertical asymptotes, all you need to do for these is, first of all, you have to simplify the problem. And then you set the denominator equal to 0. So the vertical asymptotes are going to occur at x values that are not in your domain. So it's going to be pretty much the same process as we did in the beginning with finding your domain. Unfortunately, the horizontal asymptotes do require a little bit more work. And when you first learn them, they seem overwhelming because there's a few rules that you have to remember. But once you do several of them, you do get the hang of it. So for my horizontal asymptotes, I am going to give you a few like little abbreviations that are going to help us out. Okay, I'm going to tell you right now, you do not need to memorize these abbreviations. I just kind of want to show you what's going on. I'd rather you understand these than remember what N is, remember what D is. Do not try to memorize those. That's going to be a waste of time if you do that. But here I'm going to represent N as the degree of the numerator. I'm going to call D the degree of the denominator. I'm going to call A the leading coefficient of the numerator and B the leading coefficient of the denominator. And so if you recall, by the way, the degree is going to be the highest exponent. All right, so we have three things. The first thing is if your numerator degree is less than your denominator degree, then the line y equals 0 is your horizontal asymptote. The second thing is if your numerator is greater than the denominator, there are no horizontal asymptotes. And then the last thing is if they're equal, then your horizontal asymptote is at y equals a over b. And again, this seems really complicated when you first see it, but like I said, once you get the hang of it, it's not bad at all. And we will do some practice on this. We'll do quite a bit of practice on this, so hopefully by the time we're done with the practice, it'll be a little bit more clear. The one other thing I want to say is that your horizontal asymptotes give the end behavior. And I think you might remember learning a little bit about the end behavior in the past. So that's what they're going to tell us. They're going to tell us how the ends of our graph behave. So let's go ahead and get started on this example. You'll see there's quite a bit of stuff I wrote out on here. So we're going to be finding the intercepts, we're going to be finding the asymptotes, and then we're going to draw the graph. And the first one we have is f of x equals 1 over x plus 2. I generally will start with the y-intercept because that's usually the easiest thing to find. Y-intercept, remember, you have to set x equal to 0. So I'm just going to rewrite f of x as y. I'm going to write it as y equals 0 plus 2. I end up getting y equals 1/2. Remember, with intercepts, we write them as points. So we're going to get a point, our intercept, at 0, 1/2. That one's not too bad. The x-intercepts looks a lot harder than it is here. But actually, all we're going to do is, so in general, with the x-intercepts, you set the y equal to 0. But actually, you don't even need to really think about it like that. I personally don't when I do it, because if I look at this, I look at it and it seems really confusing. Actually, what you're doing is you're more just setting the numerator equal to 0. So I end up getting 0 equals 1. That actually is a non-true statement. It doesn't mean that I can't do this problem. It doesn't mean that there's no solution. All it means is that there is no x-intercept. So that's actually going to help us a little bit. We know that if we draw a graph and we touch the x-axis, remember the x is the horizontal graph, the y is the vertical graph, that we made a mistake. So that's going to help us out a little bit. Vertical asymptotes, remember, you get that by setting the denominator equal to 0. So I end up getting x plus 2 equals 0. That gives me a vertical asymptote at x equals -2. The last one is our horizontal asymptotes. So what we're going to do is we are going to set we're going to look at the degree of the numerator, and we're going to look at the degree of the denominator. So the numerator is just a constant, which means the degree of the numerator is 0. So my denominator, the highest term is x, which means that I have a degree of 1. In this case, you'll notice my degree of the numerator is less than the degree of the denominator, which means that my horizontal asymptote, look at your little rules, horizontal asymptote is at y equals 0. So now we can actually go ahead and start drawing our graph. And you'll notice I left space for additional points. The reason I did that is because I might need a little bit more help to get a good graph. So I start with my y-intercept. It's at 0, 1/2. It's going to be about here. X-intercepts, I have none. Unfortunately, I can't do anything with that yet. I have a vertical asymptote at x equals -2, so I'm going to go over and draw that. Remember, if you have an x equals, that is a vertical line. I also will generally draw my asymptotes as dotted lines. So just to note, this is not actually a part of the graph, but it's more of a guide to help me out as I'm drawing it. It's more of a guide to show me where my end behavior is going to be, where my ends are going to go. So the other thing is I have a horizontal asymptote at y equals 0. Y equals 0 is a horizontal line on the x-axis, so it ends up looking like that. Now, I did leave space to find additional points just to help myself out. So what I'm going to do for those is I'm going to draw a XY table, and I'm going to choose a few various points on both sides of my vertical asymptote. I'm going to choose -1. That's a good one because that's on one side of my intercept. I'm going to choose +1, and then I want to choose a few over on the opposite side of my vertical asymptote, so like -3 and -4 are good. What you're going to find if you plug these back into your original equation, I'm not going to show you the work, but if you are not sure where I got them, you can ask me in class. What I'm going to do is I plug them back in. I get 1 and 1/3 and -1 and -1/2. So now what I'm going to do is I can draw these points. So I have a point at -1, +1. That's going to be right there. I have a point at 1, 1/3. That one is kind of hard to draw, but it's going to be about there. I have a point at -3, -1, and I have a point at -4, -1/2. So actually, what I also know is that my curves are going to hug my asymptotes. They're going to get closer and closer to those, but never touch them. I use a darker color so you can see. So I'm going to draw them through these points, but then keep going up. Almost touch my asymptote, but not quite. Same thing here. Keep going down. Almost touch my asymptote, but not quite. The one thing I want you to be careful of is a lot of people will draw them, and I'll show you what they look like. They draw them and they do it like that. And they're not going to really be that curved. You do want to hug up against your asymptotes, so just be mindful of that. Be careful of that. So actually I should go through these points here and get closer and closer but never touch. Same thing over here, get closer and closer but never actually touch it. So that's going to be my first graph. So we're going to do another example. We might do 2 more, but I'm going to go a little bit faster through this one. So I find my y-intercept, remember, by setting x equal to 0. And when I do that, I get a y-intercept at 0, 1. I am going to find my x-intercepts by setting my numerator equal to 0. And when I do that, I end up getting an x-intercept, there's only one of them, at -1/2, 0. So I got those 2 so far. Vertical asymptotes, I made it plural here because with functions we do occasionally have multiple vertical asymptotes, just so you're aware of that. We never have multiple horizontal asymptotes as long as it's a function, however. And everything we're going to get in this chapter so far is a function. So vertical asymptotes, you set the denominator equal to 0, which is x plus 1 equals 0. So I end up with a vertical asymptote at x equals -1. The horizontal asymptote, this one's a little bit different from the last one. If you look at your rules, you might notice that the degrees of the denominator and numerator are equal. You'll notice that they both are, the highest term is an x. So What we're going to do is we are going to be looking at look at your equation. I'll just show you what we're going to do. This is a 1x, by the way. All I do is look at the stuff I have in front of those. So my horizontal asymptote is going to be at 2/1, which is going to be just at 2. So you just are going to divide the leading coefficients of numerator and denominator here. Okay, so let's draw these. I have my y-intercept at 0, 1. Going to go there. X-intercept is at -1/2, 0. I have a vertical asymptote at x equals -1. I have a horizontal asymptote at y equals 2. So now I am going to draw some additional points in. I'm going to choose probably at least 2 on the left-hand side of my asymptote would be good. So I'm going to do one at -2. I'll do one at -3. On the right-hand side, actually, you can do as many or as little as you want here. You already have 2, which is really nice. But I'll just do one at 1. I'll do one at 2. So at -2, I end up getting a y value of 3. At -3, and remember we're plugging this back into the original equation, -3, I get one at 5/2, which is just going to be 2.5. I do recommend that if you work this out, this is one of the few times in math, graphing is one of the few times where I think it's better to keep it as a mixed number rather than in proper fraction. It makes it easier to see, or just as a decimal. At x equals 1, I get 1.5. Actually, what you're going to find is at 2, you do get something I think you end up getting like 5/3 or something. So you get more and more fractions as you go along. So I'm just going to stop here. So I'm going to draw the points I have. I have one at -2, +3. I have one at -3, +2.5. That's all I really need there. I need to make sure that I get closer and closer to these asymptotes and never cross them or never touch them. Do the same thing on the other side. Get closer and closer, never cross or touch them. And it's just going to look like that. Oh yeah, I forgot to draw my point at 1. It was 1.5, but that's fine. I ended up going through that point anyway. You don't need to draw the points if you know where it's going to go. And yeah, that's all I need for this one. Okay, let's do this last problem. I want to do this one just because it's going to look a little different from the other ones that you've seen. So we're going to start with the y-intercept. That's going to be the same. You're going to set x equal to 0. You end up getting your y-intercept, at 0, 4. My x-intercept, once again, if you try to set the numerator equal to 0, you get 0 equals 4. That's not a true statement. So actually, there's going to be no x-intercept. This one's interesting because if you try to set your denominator equal to 0, let's go ahead and try this out, you get x squared equals -1. Now, I don't know if you remember what happens when you take the square root of a negative number, but it does give you an imaginary number. We are not going to have imaginary asymptotes, so actually what that means is that we have no vertical asymptotes. And the last thing is our horizontal asymptote. The degree of the denominator is 2, degree of the numerator is 4, so the degree of the numerator is 0, because it's a constant 4. So the degree of the denominator is going to be greater than the degree of the numerator, so that means I have a asymptote at y equals 0. So I'm going to go ahead and draw what I know, which unfortunately is not very much. I'm going to draw this horizontal asymptote at 0. I'm going to draw this intercept at 4. You will notice that I don't have very much to help me draw this graph. So this is where you really need to get some additional points. And I would say choose 1 or 2 negatives, choose 1 or 2 positives. Easiest ones, in my opinion, are -1 and -2, and +1 and +2. Unfortunately, a lot of these will give you fractions. That's fine. Just deal with them. These are the ones that I ended up doing. 4/3 is 1 1/3, by the way. Once again, changing it to a mixed number is going to help you out a lot. So then you're just going to draw your points from there. And you're going to find that this ends up being, looks kind of like a bell-shaped curve here.